This is a whole set of drill bits made by Milwaukee, and they're from 1/16 to a half an inch. And what I love about them is all the drill bits are the same size when it comes to the chuck end. So whether you've got this in there and you want to put this in there, they're all the same size. Every single one. So if you got a bunch of holes to drill, you don't have to fumble looking for a key, chuck key. You don't have to have the chuck in a different position. All the ends they're all the same. It's all the same size. It saves a ton of time. Here we are at our test panel where we're going to take this and put it into pieces actually on the test panel. We're going to be using a relay, this 5-pin relay here we're not going to be using. We're going to be using the 4-pin relay. As you can see, this extra blade here is not on this one, it's omitted. This is what's known as 87A terminal. We don't have an 87A and we're not going to, so we're not going to use it. Now, we couldn't get away from the 5-pin connector. The 87A would be right here, and we've got ways to deal with that. As you can see, this wire right here, this is the 87A wire that comes out of the terminal. And what you do is you just plug it so no electricity can get out of it. That's all you have to do there. Then you can go ahead and use your 4-pin relay and just worry about your other wires. For easier explanation, we've taken and put a auxiliary fuse panel in, and that's right here. And they're really neat. You know, this comes from the battery, and over here this is negative. So you've got all these negative and all these positive. So it's time to wire it. We have to wire the relay. So 30 is this wire right here. We marked it, and it goes into here, and this circuit right here is fused by this fuse right here. That way, if anything happens, it kicks a fuse. It protects the relay and switches and things you don't want to get burned up. So you got to have that fused. And then you got to go to 85. Now that's ground. So it just comes around here. Comes to our first terminal for ground right here. And that's that. Now in this terminal here and this terminal here, this one goes to the negative on the battery, this one goes to positive on the battery. Then we're going to wire power into the relay. We've grounded it, and we've got our fused power source, but we're going to trigger the relay to come on, and that is with 86 here, which is the white. Now it comes down and it goes to a switch, which really would be your ignition switch. That is this switch here, and you can think of your ignition switch as just a switch. on-off switch. Now the 86 was white, but it changed to green here because I don't waste any wire. And then it goes to the switch you just saw. So when we flick that switch, and acting like an ignition switch, it powers the relay, tells it to turn on. Now that leaves us with number 87. And number 87 is this blue wire right here. And it goes down and under our test bench, or our test bench. It goes under here, and it comes up to this switch. And this switch is acting as our neutral safety switch. So the 87 from the relay goes to that switch, and then it branches off and it goes over here to the solenoid. Now this is a Ford solenoid, as you know, but it goes to the solenoid and it tells the engine to start. And it's the 87 wire, and it's right here. Now here's our test panel in its entirety, with the relay over here, the auxiliary fuel box. This is our neutral safety switch, and this is our solenoid. The neutral safety switch, when it's in park, will allow the vehicle to start. That's because this switch right here will only work when it's in park or in neutral. If you put it in reverse and hit it, nothing happens, because there's no power going through the neutral safety switch to the terminal on the solenoid that tells the starter to crank. So we have a couple other things. This switch here and this switch over here, this one here, they have light in them in the stem of the toggle. So when you flip it up, the light goes on. So at night you can tell, like for me, I'm real picky about that. I just don't want to look at a switch that doesn't tell me anything. I need a light to tell me it's on. Then I'm pretty sure, can't always be 100% sure, but I'm pretty sure that when that light's on, power's coming through it and power's going out of it through the ACC, which is the accessory. And that's what this is wired up to, the accessory part on this switch. The other two wires, positive and ground, are for, and including this switch, for that light to come on. If they didn't have that, the light wouldn't come on. So when that light's on at night and you're driving, you know you're okay. This switch right here, which is our neutral safety switch, you remember we had the switch that lit up, the toggle lit up. It turns out that didn't work. What was happening was the switch was on all the time, independent of the relay being turned on or off or energized. So it was supplying power to the S terminal on the solenoid all the time. And that would mean that the car would start in any gear, in any position, park, reverse, neutral, drive, whatever. It would still start. So changed the switch out, because it dawned on me that really the neutral safety switch is just a slave. And I remember when I first started doing electronics, and I'm not that good even now, but I can flub my way through. It was so hard for me to wrap my head around a positive wire, and then you put something in the line with no negative at all, and it works. It comes in, goes out. That was just so hard for me. I could not really figure that out, why it would work with no negative. Well, it does. And there's a lot of things in the automotive that are slaves and are only on the power side. And this is one of them. As soon as I changed it to just a 2-pole switch, single throw 2-pole, it worked. But then I had a connection problem with one of the wires. Once I found that and fixed that, then I got the whole enchilada. So the whole reason why you draw out a plan, it's kind of like the theory, kind of like the fundamentals, and you can refer to it as you go on, because as these circuits get more and more complicated, and this is a very easy one, you can get lost real easy. If you try to do it by memory, you're going to screw up. So writing it down first and having a plan, if it looks good there, it'll guide you where you're supposed to go. Now, you put everything on our test panel like I have, and you find what works and what doesn't, just like I did. If you think about it, neutral safety switches don't have lights on them, so what else can it be? It can only be a slave on the power side. So let's see what we got. This should work now. We should have a functioning neutral safety switch. Let's see what we got. We'll energize the relay. That's park. Reverse. Neutral. Drive. Low. Or overdrive, drive, low 2, low 1, whatever you want. I got a 4-speed automatic, so. But there it goes. There, it's working. So you know that when the switch is not in the right position, according to the gear change lever, there's not going to be any power going to the S terminal on the solenoid, which means the motor will not start. Even though right now the relay is actuated, it's on. Okay, here's our shifter, and this is our neutral safety switch. Now you can see that there's 4 terminals. I'm going to be using 2 terminals for the neutral safety switch and 2 terminals for the reverse lights. So I just have to hook them up, and whichever position the gear shift lever is in, it's going to activate that switch based on its position. So if it's in the wrong position, it won't supply power to the S terminal on the solenoid. And if it doesn't do that, the engine won't start. Put it in the right position, the switch goes on. It's in park, it starts. It's in neutral, it starts. Reverse, drive, low, second, overdrive, no, it's not going to work. And that's why. So that your vehicle doesn't take off. Like, you know, someone accidentally starts it, it's in gear, goodbye. The high performance car, oh God. Even if it's a Volkswagen, pins you against your bench, oh my God, just crazy. And dangerous to everyone else around you. So that's why NHRA demands that you have to have one. You can't race unless you do have one. And I don't blame them. It's a good idea, and it makes you safe, and that makes everyone else safe around you. And I think that's the main idea. It's true, I was born dyslexic, but Mother Nature was kind to me. She made me cross-eyed as well, so I see as good as you do.